Yeah.
So this
Yes.
is the inconsistency in Ampere circuital law,
Yes.
and I have written here. After that, this inconsistency basically is given by Maxwell. Okay, scientist Maxwell.
Hmm.
Uh, okay, so why this is the inconsistency here, and why if you are placing a compass needle here, so why there is a magnetic field here,
Yes.
and here if you will see, here is complete vacuum. If I have suppose remove this. Okay, these are the plates of the capacitor. So is there any current in this region?
No.
No current, na? So
Yes.
then
No.
how can we say that there is a magnetic field? Magnetic field is produced by the current.
Yes.
Okay. So these things are explained by the Maxwell. Okay. So he gives the idea of the displacement current. Idea of the displacement current. So basically, what happens when the capacitor is connected with the battery? Okay. When the
Okay.
capacitor is connected with the battery, so there is a charging of the capacitor.
Yes.
So basically, what happens? The negative charge increases on this plate, so the positive charge will increase on this plate. Okay. So
Okay.
basically, what is happening? This capacitor is charging. Charging means the charge on the capacitor is increasing.
Yeah.
There are two plates of the capacitor: negatively charged plate and positively charged plate.
Yeah.
So with time, the negative charge on this plate will increase, and with time, the positive charge on this plate will increase. So due to that, there will be the current here in
Yeah.
this circuit. In this wire, there will be the current. But if I am talking about what will be the current in this region, so as there is no wiring connection here, there is complete vacuum. So there is no current here basically. But one thing here, this is positive charge here and this is negative charge. So there will be some electric field here. Okay, there will be some electric field,
Yeah.
and
Yes.
this electric field will change with time. Why this electric field will change with time? Because this charge on the capacitor with time is changing.
Yes.
That is why in between the plates of the capacitor there will be the electric field. Basically, these are the electric field lines. Okay, in between the plates of the capacitor. So here will be the electric field, and this electric field is changing with time. Changing with time. Why this electric field is changing with time? Because charge on the capacitor is changing.
Changing it.
Basically, these are the electric field lines. These arrows represent the electric field lines. Okay. Okay, fine. Uh, After that, what Maxwell said is this. Maxwell said that no, not only current produces the magnetic field, not only current produces the magnetic field, but a changing electric field in vacuum also produces the magnetic field. Now we got the answer.
Yes.
Earlier, I have told you here, you can see here. Here I have told you there is a magnetic field, but here is no current. I have told you, na?
Yes, sir.
Here this magnetic needle is deflected, means there will be the magnetic field here, but here is no current. But now we got the answer why there is a current here, because in between the plates of the
The
capacitor
displacement.
there is a changing electric field.
Hmm.
There is
Yeah.
a changing electric field, and due to that changing electric field there is a current given by the Maxwell known as the displacement current. So basically you can say that in between the region of the capacitor in vacuum region there will be a current that is known as the displacement current. So that's how the concept of the displacement current is there. So here will be some will be the displacement current. So I am representing displacement current I suffix D. Okay.
Okay.
So I suffix D will be the displacement current. Okay. Now conduction current. Conduction current is basically the normal current that is flowing in the wire is known as the conduction current. This I is known as the conduction current. Okay.
Okay.
So conduction current is basically the normal current that is flowing in the wire is the conduction current. So conduction current is simply, you can say, conduction current is this I that is flowing in the wire. You can say
Okay.
wire. Now displacement current. Displacement current, I have told you why there is a displacement current, because of this change in electric field.
Yes.
And why the electric field is changing? Because the charge is changing. Charge is
Yeah.
changing on the plates of the capacitor. Now you can see displacement current is basically a current due to changing electric field or changing electric field and electric flux. Means why here it is here I have written the electric flux also. Why? Because this is the plate of the capacitor.
Yeah.
Okay. Actually, the video camera is not working, but okay, I can take the example of that a plane is there and electric field lines are going like this. Okay,
Mm.
so earlier also I have told you the concept. Okay, I don't know why this is the camera is not working today. I don't know. It, it was fine yesterday. I don't know what happened. Okay, by the way, so basically number of electric field line crossing the area is known as the electric flux. So basically here
Yeah.
you can see these are the electric field line and crossing the area of the plate of the uh, capacitor perpendicularly. So basically it will also become the electric flux. So that is why we can say that a current due to the changing electric field or electric flux is known as the displacement current. And this displacement current is given by epsilon naught d phi e by dt. d phi e by dt means phi e means the electric flux,
Electric. Yeah.
and this is the formula of the electric flux, ea cos theta. ea
First
cos
thing.
theta. So this is basically the concept of the displacement current. Okay.
Okay.
Now after the experiment is done by the Maxwell, and he find it out that at this point x and at this point y, the magnetic field is same.
Yes.
If you are saying that at this point x and at this point y, the magnetic field is same, then here and here at point I, at this point and at this point,
Yes.
you can say the current will be same. So in the wire there is a displacement current. Okay. So in the wire there is a conduction current and here is the displacement current. So from this experiment, it is implied that the conduction current is equal to the displacement current. Both are equal always.
Equal.
Okay. So
Okay.
conduction current and the displacement current will always be equal. Okay. So now we will drive one relation. Now got it now? Why there is a conduction current? Why there is a displacement current?
Yes.
Because there is a change in the electric field. Okay.
Yeah.
There is a change in the electric
Or
field.
electric flux, right?
Yeah, or electric flux also you can.
Okay, sir. Okay.
After that, we know that here is in wire there is a conduction current, and in
Yes.
between the plates of the capacitor there is
There
a
is
displacement current.
displacement. Yes.
Displacement current. So earlier, the if you write the ampere circuital law, then it is v line integral of magnetic field, that is v dot dr is equal to mu naught into I is the conduction current taken by the ampere. So
Yes.
earlier I is the conduction current. Now modified Ampere's law is given by the uh, actually it is modified by the Maxwell. So Maxwell said that the line integral of magnetic field along a closed path is equal to mu naught times of the conduction current plus displacement current.
Oh,
So this can be written as line integral of magnetic field is equal to mu naught times of the what is the conduction current? Conduction current is simply the current I
yeah.
flowing in the wire.
Yes.
It is simply I, and displacement current is epsilon naught d phi e by dt.
DT. Yeah. That's displacement current, right?
Yeah, that is the formula calculated by the Maxwell displacement. This is I, and
Yes.
displacement current is epsilon naught
Okay.
d phi e
By D.
by dt. So basically, this is the modified Ampere's law.
Okay.
This is the modified Ampere's circuital law, and this is also known as Ampere's Maxwell law. Okay, so
Okay,
this
sir.
is basically known as the Ampere Maxwell law. Or you can say modified Ampere circuital law. And remember that in wire, or a conductor, the displacement current is equal to 0. In conductor,
Yes.
displacement current is equal to 0.
Mm.
And we know that in between the plates of the capacitor, the conduction current will be 0.
Yes.
Okay.
Yeah.
So plates conduction current is equal to 0. Now got it? Why here is a magnetic field? Because in between the plates of the capacitor, there is a changing electric field.
Yeah.
Okay, so now you can just take the screenshots. Earlier you have done this, no? You have noted this
Yes, sir.
inconsistency in Ampere circuit. In the last class I have told you.
Yes.
So that's how the idea of displacement current is given by the Maxwell.
Done, sir. Done, sir.
Completed?
No, sir.
Okay. So this is the electric flux I have told you in the electrostatics. E is the electric field, A is the area, cos theta. Theta is the angle between the electric field vector and the area vector.
Done, sir.
And remember this point, conduction current is always equal to the displacement current. And write on this also, modification of Ampere circuital law.
Done.
Oh, after that, the modification of Ampere circuit law. After that, there are Maxwell equations. Okay, there are Maxwell equations. These equations are given by the Maxwell. Okay,
Okay.
basically, these are the 4 equations. Okay,
Okay.
and these equations you already know. Okay, because Maxwell has taken these equations from the concept of the previous scientist. Okay,
Okay.
like first equation of the Maxwell is simply the Gauss law of electrostatics. Gauss law in electrostatics is the first equation of the Maxwell. Okay, so
Okay.
basically all the basic principle of electromagnetism, talking about the Maxwell equations.
Yes.
So all the basic principle of electromagnetism can be explained in terms of the 4 fundamental equations known as the Maxwell equations. Okay.
Okay.
So basically with the help of these Maxwell equations, okay, with the help of these Maxwell equations, all the chapters till now you have studied electrostatics. You have studied the electrostatics. After that, current electricity. After that, moving charges and magnetism. After that, electromagnetic induction. After that, okay, after the electromagnetic induction. So these all the things, all the chapters or all the mm, topics you can explain with the help of just using these 4 equations. Okay.
Okay. Yes.
Basically, Maxwell equation is not the part of your syllabus, but you should know at least what are the Maxwell equations.
Okay.
What are the Maxwell equations? Basically, electromagnetism is this is the electromagnetism. I have written here electromagnetism. So electromagnetism means the part of the electricity and the magnetics. Electricity means the those chapters comes under the electricity, that is the uh, electrostatics and current electricity. And magnetism means that the moving charges and magnetism, natural magnetism, earth magnetism, electromagnetic induction. Okay, so all these chapters can be explained with the help of the Gauss law of Maxwell's equation. So in Maxwell equation, first Maxwell equation is given by the Gauss law of electrostatics. Okay, so basically first Maxwell equation is the Gauss law of electrostatics. Okay, so this is a 3D surface. This is a 3D closed surface here. You can see here. This surface
Yes.
is a 3D closed surface. 3-dimensional, it is 3-dimensional.
Yes.
A cuboid, this is the cuboid.
Yeah.
Basically. So basically, this is a 3-dimensional cuboid, and inside this cuboid, a point charge is placed. And we know that the point charge will produce the electric field.
Yeah.
The point charge will produce the electric field, and these are the electric field lines due to this point charge. So, what is the electric flux? This is the electric flux given by this charge.
Yes.
Okay.
Okay.
Electric field flux is basically the electric field line crossing an area. Okay. So, Gauss law of electrostatics we have studied. What is the Gauss law of electrostatics? It is given by the total magnetic flux. Total magnetic flux E dot dA is equal to the total magnetic flux through any closed surface is equal to charge enclosed by that surface divided by the epsilon naught. This was the Gauss law of electrostatics.
Yeah. Yes.
E dot dA is equal to Q in by epsilon naught, means total electric flux through a closed surface, okay, is equal to charge inside divided by the epsilon naught. So basically this is the first equation. Second is the Gauss law in magnetism. So Gauss law in magnetism says that the flux magnetic flux through a closed surface is equal to 0. That is B dot dA is equal to 0.
Yeah.
So this will be 0 because suppose this is a sphere, and in this sphere suppose there is a magnet like this. This is a magnet. Why I am saying why Gauss law in magnetism means why the magnetic flux through any closed surface is equal to 0. So this is a sphere,
Yeah.
and this is the north pole of the magnet. This is the south pole of the
So
magnet. So the magnetic field line through this magnet will be like this, like this, huh?
yeah.
Starting a magnetic field line is starting from the north pole and entering to the south pole.
Yeah.
So now what is the leaving flux here? This is the leaving flux. This is the leaving magnetic flux,
Yes.
and this is the entering magnetic flux. So here leaving magnetic flux is equal to the entering magnetic flux. So the flux that is entering and the flux and that is leaving both are equal. So how what will be the net magnetic flux? For example, water is entering like this,
Yeah.
and same amount of water is leaving like this. So how much amount of water will be there inside? Means, for example, just wait. Suppose 5 liter of the water entered first in this sphere, and same 5 liter after some time you can say 5 liter just leaved this surface. So
Yeah.
what will be the net amount of water inside?
0.
0. So this is the
Okay.
magnetic flux, means the magnetic flux entering
Yeah.
and is equal to the magnetic flux leaving. So you can say the
Okay.
net magnetic flux is equal to 0.
0. Okay.
But remember, this is for the closed surface like sphere.
Okay. Okay.
So net magnetic flux through a closed surface is equal to 0. After that, the third equation of the Maxwell is Faraday's law of electromagnetic induction. Simply Faraday's law of electromagnetic induction. What is the Faraday's law of electromagnetic induction? Change in the magnetic flux induces the EMF.
Yeah.
Change in
Induces
magnetic flux induces an EMF.
Yeah.
And this EMF is equal to minus d phi by
D.
dt. So we know this, but this thing can be written in one another form also. This statement statement can be written in another form also. Changing magnetic field induces an electric field. Electric field. So basically, this statement is same as this statement. Magnetic flux is basically the number of magnetic field line, and EMF basically an electric field. Okay,
Yes.
EMF, with EMF there will be the electric field. So basically, changing magnetic field induces the electric field. So the EMF can be written as E dot dl this is equal to minus d phi by dt, and phi is it is right here phi b. Phi b is representing the magnetic flux.
Okay.
Magnetic flux. So basically, this is the third equation of Maxwell. Fourth, Ampere's Maxwell law. Just I have discussed Ampere's Maxwell law. Line integral of magnetic field along a closed path, that is B dot dl, is equal to mu naught times of the conduction current plus displacement current. Okay, so it can be written as B dot dl is equal to mu naught times of conduction current is basically I, and what is the formula for the displacement current? Epsilon naught d phi e by d phi by e by dt. Fourth equation. Fourth equation of Maxwell. Okay, so first note down this fast, take the screenshot, then next we will proceed.
Okay. Done. 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 Done.
Okay, okay. So basically, these are the statements simply you should remember this. What is said by the Faraday? A changing magnetic field induces an electric field, or the induced induced electric field is perpendicular to magnetic field. Okay, and Maxwell said that a changing electric field induces the magnetic field, and that induced magnetic field is perpendicular to the electric field. So you can see here. Here is this is the magnetic field.
Yeah.
And here also the magnetic field.
Yes.
So basically, what is the cause of this magnetic field?
Because of the displacement current.
Yeah, displacement current, you are right. But what is the cause of that displacement current? Changing electric field?
Yeah, changing electric.
So what we can say indirectly? The magnetic field is due to the changing electric field.
Yes.
This is said by the Maxwell. Earlier what Faraday said? Faraday said that changing magnetic field produces the electric field.
Yeah.
Now, when you will calculate the direction of the magnetic field here, or if you want to calculate the direction of the magnetic field here, okay, so that magnetic field will be perpendicular to the electric field. Okay, that
Okay.
magnetic field will be perpendicular to the electric field. So this is the direction of the electric field. No? This is the
Yeah.
direction of the electric field.
Yes.
And here, when you will find the magnetic field, so magnetic field will be like this. So electric field is along x-axis and magnetic field is along z-axis.
Oh,
So
yeah.
electric field and magnetic field both are perpendicular. Okay.
Okay. Done. Sir.
Okay, just wait for 1 minute.
Okay.
Okay, clear? Clear?
Yes, sir.
Okay, so after that, basically, if you are changing a magnetic field, so you will get a electric field.
Yeah.
Okay, and
Okay.
that electric field will be perpendicular to the magnetic field. And if you are changing an electric field, you will get a magnetic field, and that
Yeah.
magnetic field will be perpendicular to the electric field.
Hmm.
Okay. Uh, After that, there is a derivation basically. Uh, this is the derivation. Okay. How we got the displacement current? Okay, how we got the displacement current? So, okay, I am doing it again. Okay. So this is the condition I have discussed earlier. Means charging of the capacitor is there, and charge on the capacitor is increasing. That is why the electric field is increasing, and due to the changing electric field, there will be the displacement current. Now, how the displacement current is given by epsilon naught d phi E by dt. So this thing I will prove. Okay. So one thing there is a electric field between the plates of the capacitor.
Yes.
The value of the electric field between the plates of the capacitor is given by sigma by epsilon naught. Earlier we have discussed in case of the capacitor, parallel plate capacitor. Sigma is the surface charge density. Okay.
Okay.
Sigma will be the surface charge density. Sigma is the surface charge density. And what is surface charge density? Sigma. Sigma is equal to charge on the plates of the capacitor divided by the area of the plate. Okay. So this sigma by epsilon naught can be written as 1 by epsilon naught, and in terms of sigma, you will put charge divided by A. Okay.
Okay.
You can put charge divided by area.
So why are we putting charge divided by area?
Why we putting charge divided by area? Why? Because this charge is changing here.
Yeah.
Okay. And with the help of this, we will get some formula that you will know. That you will get to know later. Okay. Why we are putting this value. Okay, so so basically this is the electric field value we get here. Now if I am writing electric field in electric flux in between the plates of the capacitor, that is given by E dot dA, E dot A.
Yeah.
And this is given by EA cos theta.
Yes.
So what is the value of the electric field? This is the value of the electric field between the plates of the capacitor.
Yeah.
Area of the plate A cos theta. Now, the angle between the electric field and the area vector of the plate will be 0 degree.
0. Yeah.
You can see here, electric field is like this, and area vector will be perpendicular to this plate.
Yes.
Okay, and perpendicular to this plate is this. So basically, angle will be 0 degree. So here you will write cos of 0, and cos of 0 is 1. So electric flux in between the plates of the capacitor, or electric flux, will be 1 by epsilon naught into Q. A and A will be cancel out, and cos 0 is 1.
Yeah.
Now this charge is changing.
Yeah.
Charge on the plates of the capacitor is changing continuously.
Yes.
Because there is a charging of capacitor. Now differentiate this equation number 1 with respect to time. So you can write it as d phi E by dt is equal to 1 upon epsilon naught dq by dt.
Okay.
Why I have written 1 upon epsilon naught? Okay, so why I have written this? Okay, so basically it will q by it is equal to q divided by epsilon naught. So you can write it as d by dt of q by epsilon naught. Okay.
Okay.
Now this epsilon naught is constant term.
Yeah.
But this charge is changing continuously.
Yes, sir.
So we can write it as d phi E by dt is equal to 1 upon epsilon naught. You can take out of the differentiation, it will
Yeah.
become dq by dt.
Yes.
And what is this dq by dt? Dq by dt is basically change on the charge on plates of the capacitor. What is this dq by dt? Change of, or you can say rate of change of charge on the plates of capacitor. Rate of change of charge on
Yep.
plates of capacitor.
Mm.
This is dq by dt. This is not the rate of flow of charge. Basically, this is the rate of change of charge on the plates of the capacitor. And basically, why we are getting the displacement current? Due to the rate of change of charge on the plates of the capacitor. Due to the change in the charge of the plates of the capacitor, there will be the changing electric field, and due to
Yes.
that changing electric field or electric flux, we are getting the displacement current.
Yeah.
So dq by dt is basically the displacement current, you can write. So you can write this is as this will be the displacement current. So displacement current will be from this equation epsilon naught d phi e by dt. So basically this is the derivation of the displacement current. So you can write here derivation of displacement current. Displacement current. Okay, now you can just note down this. This can be asked in your exam also.
Okay, sir.
Derive the expression for the displacement current.
Done, sir.
Done.
Yeah. Done, sir.
Done. After this, we will discuss the how the electromagnetic wave can be produced. How the electromagnetic wave can be produced. See the name electromagnetic.
Yeah.
So basically, in electromagnetic wave, there is the electric field and the magnetic field, and that electric field and magnetic field is continuously changing with respect to time.
Yeah.
So in electromagnetic wave, there is an electric field and magnetic field changing with time. Source of electromagnetic wave is the accelerating charge particle. Source of electromagnetic wave is an accelerating charge particle. So this point you have to remember. So accelerating or oscillating charge is the source of electromagnetic wave. Okay, and how we get the oscillating or the accelerating charge in LC circuit. So in LC circuit, we get the oscillating charge. Okay. So basically, LC circuit was removed now from your syllabus. Okay. This is the topic in alternating current AC. So you have to remember this point.
Okay, sir.
What is the source of electromagnetic wave? Accelerating or oscillating charge? Okay. Accelerating or take the screenshot first.
Okay. Done, sir.
Done. Okay. So now see if I will say how there will be the electromagnetic wave. So this will be the graphical representation of electromagnetic wave. So basically this is y-axis.
Yeah.
and this axis is x-axis, and this axis is z-axis. So basically, the electric field is oscillating like this.
Yes.
See here, the electric field is oscillating along along the y-axis. Okay, so you can see here is electric field is increasing and increasing and increasing. Now electric field is decreasing and decreasing and decreasing and decreasing, and then electric field becomes zero.
Zero.
Now electric field is increasing, 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 increasing in negative direction.
Yeah.
Then electric field is decreasing, decreasing, and decreasing, and decreasing in negative direction. Again, the electric field
Zero.
becomes zero, and then again the electric field is increasing in positive direction. Again, the electric field will become maximum, and again the electric field is decreasing in positive direction.
Yeah.
This is known as the oscillating electric field, and same is the case. And this oscillation is taking place in y direction or not?
Yeah.
Okay, same is the case with the magnetic field, but the magnetic field oscillation is taking place in z direction. We have considered this, and the whole wave is propagating along the x direction. The wave propagation is along x direction, and basically electric field is oscillating towards the y direction. Remember this point, and magnetic field is oscillating towards the z direction, and the direction of the propagation of the wave means in which direction the wave is going is in x direction. Okay, is in x direction. So basically this is the graphical representation of electromagnetic wave. So you can just take the screenshot. Done. Okay. Now wave chapter have where you have studied the wave. Do you remember some old memories?
No, sir.
In 11th class there is a chapter wave, and what we are studying, a wave.
Yeah.
So electromagnetic wave is also a wave, na?
Yeah.
So first we should know about the wave.
Yes.
Okay, so for a moment or for 10 minutes we will go in 11th class. Okay. And from there we will discuss some of the concept of the wave. Okay. Equation of the waves and what are the properties and what are the formulas related to waves. Okay, and after that we will discuss what will be the equation of the electromagnetic wave. Okay, so brief introduction to the traveling wave. Basics related to the traveling wave. Basically these all things are the part from the 11th class. Okay. So suppose this is a wave.
Yeah.
This is x direction. This is y direction. So this is a wave, a traveling wave. This wave is traveling.
Yes.
Like this. So first term related to the wave is the wavelength. Wavelength is represented by lambda. And what is this wavelength? Length of a wave is known as the wavelength. Means this length is known as the lambda. Wave number is represented by k, and this is given by 2 pi by lambda. And what is time period? Time to complete one wave. So in going, suppose a particle is here, the particle is going from here to here to here to here. Finally, in reaching here, the time taken by the particle will be time period. Now frequency is 1 upon time period. And what is frequency? Frequency is the number of waves, number of waves in 1 second. Okay. So number of waves in one, you should know what is the relation between the frequency and the time period. And there is angular frequency omega. So many
Yeah.
times we have discussed in the AC,
Yeah.
omega, and omega is also given by 2 pi by t, because omega is equal to 2 pi into f, and f is 1 by t. So instead
Yeah.
of f, we can put 1 by 2. So omega can be written as 2 pi
2
by
pi by t.
t. Now this is the important point. All the other points I think you should know except this wave number. This speed of the wave is omega y k, remember. Speed of the wave is omega y k.
Okay.
Okay. And further, when you will solve it, omega y k, omega can be written as 2 pi f, and k can be written as 2 pi by lambda. So basically, speed of the wave is given by frequency of the wave into the wavelength of the wave.
Okay.
Okay. So these are the points related to the waves. Now, equation of the wave, how we write the equation of the wave? For example, this equation of the wave. Okay. So this is a wave like this,
Yeah.
and suppose here is some particle. Here is some particle, and at this position, this particle is oscillating in this direction, in y direction. Here the particle is oscillating in y direction.
Yeah.
Okay. And here is another particle which is also oscillating in y direction. But see here, the displacement of particle is this. Here
Yeah.
the displacement of particle is this. Means at different points,
Yeah.
at different points, the displacement of different particle will be different. So basically, uh, the displacement of the particle will be a function of x. Okay. And with time also, as the time is changing, the displacement of the particle is changing. Okay. This particle will be oscillating like this.
Yeah.
If you are taking this as a particle, this particle is oscillating like this also. Okay. And this particle with distance, the displacement of the particle is also changing. So basically, the displacement of the particle is a function of time also. So basically, the displacement of the particle is a function of displacement and time.
Fine.
And this wave is a sinusoidal wave. So equation of the wave can be written like this: y is equal to a sine kx plus minus omega t, or y is equal to a sine omega t plus minus kx. And what is a? A is the amplitude of the wave.
Okay.
Amplitude, or you can say maximum displacement of the wave. Okay, this will be the amplitude of the wave. This is the amplitude. So A is the amplitude of wave particle. Okay, so equation of the wave can be written in this form, or can be written in this form. In both forms, you can write the equation of the wave. Now, if it is written that y is equal to a sine omega t plus kx, in between, if there is a plus sign,
Yeah.
then, and with k there is an x, then this wave is going in x direction, and this plus sign will, if the here is a plus, then you will say the wave is traveling along negative x direction.
Okay.
For example, this is the case. In between, there is minus sign.
Yeah. So positive expression.
So positive, but here is x.
Yeah.
So wave is traveling along positive x direction. If it is written that y is equal to a sine omega t minus k into z,
Yeah. So
then what you will
plus
say?
z direction. Positive
Plus
z
z
direction.
direction. Very good. So what is y? Y is basically the displacement of the particle. A is basically the amplitude.
Okay.
So these are the basics related to the wave. Okay, so take the
Okay.
screenshot. So now we will write the equation of the electromagnetic wave.
Okay. Done. Sir. Done. Sir. Done. Sir.
Okay. After that, we will write the equation of electromagnetic wave. I have told you in electromagnetic wave, there is electric field and magnetic field. So
Yes.
basically, we will write the equation of electric field and we will write the equation of the magnetic field. Okay. So
Okay, sir.
equation of electromagnetic wave. So basically here, see here, along the x direction, the wave is propagating. The
Yeah.
direction of the propagation means the direction of the motion of the wave, you can say.
Okay.
This is the direction of propagation. And in y direction, the electric field is oscillating.
Yeah.
In z direction, the magnetic field is oscillating. Okay. So equation of the electric field. So basically, equation of electromagnetic wave is basically the equation of electric field or equation of the magnetic field. So electric field, I have told you, will vary sinusoidally like this. And electric field is changing in y direction.
Yeah.
Means electric field is along the y direction.
Yeah.
So here the electric field is changing along the y direction.
Right direction.
And j cap is representing the unit vector along the y direction. I have told you earlier also.
Yeah.
So
Yeah.
this thing we can do by ourselves. This is not a very big deal. So
Okay.
basically, if you will write the equation of the electromagnetic wave or equation of the electric field, equation of the electric field, it is given by E is equal to E naught sine kx minus omega t into j cap. Why j cap? Because electric field is along the
Y direction.
y direction. Okay.
Okay.
So now we can just modify it. It will be,
So
yeah,
if it's in negative y direction, it will be minus j, right? Minus j cap.
yeah. Negative y direction, it will be minus j cap. So this can be written like this. This is EY and this is E naught and this is sine. K can be written as 2 pi by lambda and this is x. And what is omega? Omega can be written as 2 pi by t
Yeah.
into j cap.
Yes.
So now you can just take, this is sine and 2 pi you can take common. So here
Yes.
will be x by lambda
Yeah.
and here will be 1 by t.
Yes.
Further you can change it. Ey is equal to E naught sine 2 pi x by lambda. What is 1 upon time period? Frequency.
Yeah.
So in this form also you can write the wave equation. Okay. And E naught is basically the maximum value or the amplitude of the electric field. In the same way, you can write the equation of the magnetic field. And I have told you the magnetic field is changing along the z direction, or you can say the magnetic field is oscillating along the z direction. So basically, here is the magnetic field along z direction.
Yeah.
Okay, this x is the direction of the propagation of the magnetic field or electromagnetic wave, and V naught is the maximum value of the magnetic field. So equation of the magnetic field is along z direction. V is equal to V naught sine kx minus omega t into k cap.
Yeah.
Okay, so take the screenshots.
Done, sir. Done, sir. Done, sir. Done, sir.
So equation of the electromagnetic wave we have completed. Okay. So this is the electric field. Basically, what is electromagnetic wave? If someone is asking what is electromagnetic wave, electromagnetic wave is basically the oscillating electric and magnetic field. So for the equation of the electromagnetic wave, we have to write the equation of the electric field and equation of the magnetic field. Simple. Okay. So
Okay, sir.
equation of the electric field is this, and this equation of the electric field can be written in other forms also. Okay. This equation of the electric field can be in other form also. Okay.
Okay, sir.
And this is the equation of the magnetic field, and this can also be in other form also. We will see in the questions. Suppose this question is given to us. This question is given to us. They are asking speed of the electric field in a plane electromagnetic wave. EMW means electromagnetic wave.
Electromagnetic. Yeah.
The electric field in a plane electromagnetic wave is given by, this is the equation of the electromagnetic wave. Okay, this is the basically the equation of electric field in electromagnetic wave.
Yeah.
Basically, the electric field in a plane electromagnetic wave is given by this. What is the direction of the propagation? What is the speed of the wave? Can you tell me the direction of the propagation? Very easy question. See. What I have told you for the direction of the propagation. What was the equation of the electromagnetic wave we have written? Ey is equal to E naught
E naught sine
kx plus minus omega t. Okay, so you can write plus omega t. So with x there is k,
yeah.
and with t there is omega.
Yeah.
And I have told you, if in between there is a positive sign, what will be the direction of the propagation?
It will be
Negative.
negative.
Negative
Yeah.
means what? Negative, and this will be
Yeah.
decided by this x.
Hmm.
Okay, so negative
Okay.
x direction.
Oh,
Negative x direction will be the direction of propagation. Now, can you tell me the value of k? I have told you with x there will be k.
hmm.
So this is x, so means this will be k.
Yes.
This is k.
Yeah.
And with t there will be omega, so means this will be
Yeah.
omega. They are asking the speed of the wave. What is the formula for the speed of the wave? Speed of wave is equal to omega by k, na?
Yeah.
Okay, so speed of wave is omega by k. That is why I have written like this.
Hmm.
So what is omega? Now tell me what is omega. Here will be,
One.
just a minute. This will be the 10 to the power 11. Now tell me what is omega.
1.5 into 10.
Yeah. So we will put here, instead of omega, 1.5 into 10 to the power 11.
Yeah.
What is K?
0.5 into 10 raised to the power 3.
Yeah, 0.5 into 10 to the power
3.
3. So can you tell me the answer? Five threes are 15, and this is 11 minus 3, 8. So 3 into 10 to the power 8 meter per second. Okay.
Okay.
3 into 10 to the power 8 meter per second. So don't think this is very hard. This is very easy. See, if here is plus sign, means the wave is going in negative direction.
Negative. Yeah.
Negative at y or z will be decided by if here will be x with k. If there will be x,
Yeah.
then the wave is going in x direction.
Yes.
If with k there will be y, the wave is going in y direction.
Yes.
Okay, so just copy this. Basically, this is A part and this
Yes.
is B part. Okay, just take the screenshot once again.
Okay.
Completed?
Yes.
Now, in an electromagnetic wave, what is the relation between the peak value of the electric field and magnetic field? So, peak value of the electric field divided by the peak value of magnetic field is equal to C. Okay, take the screenshot. This is very important relation, remember. Done?
Yes.
Okay. Now there is permeability and permittivity. Okay, so here in air or free space, in air, vacuum or free space, speed of light. Basically, what is light? Light is an electromagnetic wave.
Yeah.
Okay, light. So speed of the electromagnetic wave is equal to this. Okay, all the terms I have written here, and in other medium, the speed of the wave is given by mu m and epsilon not epsilon m, and there is a term relative permeability. Relative permeability, na?
Yeah.
Relative permeability is equal to the permeability of medium divided by permeability of free space. Okay.
Okay.
Here I have written mu m is the permeability of medium. Relative permittivity in electrostatic, I have told you relative permittivity or dielectric constant. Relative permittivity or dielectric constant is given by epsilon m by epsilon naught, and epsilon m is the permittivity in medium. Okay.
Okay.
So this relation and this relation is very important. So we will use this in this to solve this question. Okay.
Okay.
Okay, so take the screenshot.
Done.
Done. Ziyad, completed?
Yes, sir.
Okay, write down this also.
Done.
Now we will solve this question. A plane electromagnetic wave Ez is equal to this. Equation of electric field of electromagnetic wave is given.
Yeah.
Okay, this equation is given to us. First information is given.
Yeah.
And a plane electromagnetic wave. This time the electric field is oscillating along z direction.
Yeah.
Okay, I have told you the electric field can be in any direction. We have
Yeah.
just considered that electric field is along y direction. Electric field can also be in z direction also. Okay, there is no problem. Okay,
Okay.
we define the coordinate by ourselves. Okay, so Ez electric field is like this, propagates in non-magnetic medium. What is the meaning of the non-magnetic medium? Means that the permeability of that medium is equal to the permeability of the free space.
Yeah.
Okay,
Okay.
of dielectric constant. So basically dielectric constant of the medium is asked. So basically this is an electromagnetic wave. Okay,
Okay.
here is an electromagnetic wave, and this electromagnetic wave is propagating in a medium, and we do not know what is that medium, but one information is given, that medium is a non-magnetic medium, and the equation of the electric field is given of that wave, electromagnetic wave. Now can you tell me what is k and what is omega and what is direction of the propagation?
Direction is
Why?
negative x-axis.
Very good. Direction of propagation is
Negative
negative of x.
x-axis. Yeah.
And what is omega?
Omega is 16 to 10 is to
Very
3.
good, very good, very good, very good. This will be omega. And what is k?
K is u.
No, this is not u. This is 4. You are right. This is u. This is k.
Yeah.
This is basically not u. This is 4.
Oh,
1, 2,
okay.
3,
4.
4.
Okay.
Now this question is finished. Okay. After that, here now we want to find the dielectric constant.
Yeah.
So actually now in this chapter there is a problem. That problem is the concept of the electrostatics and concept of the magnetics will be used. This is the problem. But this is the problem for the student because they cannot recall the old formulas.
Yeah.
If suppose I am asking what is dielectric constant. So dielectric constant is basically is given by the epsilon m divided by epsilon naught. That is why here I have written all the formulas, respective formulas I have written here, so that there is no problem.
Mm.
Okay.
Okay, sir.
Permittivity in a medium is also known as the dielectric constant. Since C, K is written here. Okay. So this dielectric constant we want to find.
Yeah.
Okay. Now how we will find this dielectric constant? What is this? 100?
Yeah, 100.
100 is E naught. Okay.
Okay, sir.
100 is E naught. Okay. So there is a relation in between E naught and V naught. There is a relation in between E naught and V naught. And
Yeah.
so basically dielectric constant we want. Now how we will find the dielectric constant? if I will want to find the speed of the wave, speed of the wave is given by omega divided by k. What is
Yeah.
omega? Tell me first.
6 into 10 raised to 8.
What is k?
4. 4.
4. So basically it will be 3 by 2 into
Yeah.
10 to the power 8 meter per second.
Yes.
And what is speed of light? C. C is
Yeah.
the speed of the light.
Yeah.
I have written here speed of light. Okay, you can see. C is the speed of the light. And the speed of the light can be written as this in vacuum. But in if speed of light is in some other medium, light is if electromagnetic wave is traveling in some other medium, it will be 1 upon mu m epsilon m.
Yeah.
So basically, in this medium, the speed of the electromagnetic wave is 3 into 10 to the power 8 can be written as c and
Yeah.
divided by 2 meter per second.
Okay.
This is the
Yes.
equation number 1.
Yeah.
Now, speed of electromagnetic wave in any medium can be given by 1 upon mu m into epsilon m. And what is mu m here is equal to mu naught. Why? Because the medium is non-magnetic medium.
Yeah.
That medium is non-magnetic medium.
Yeah.
Okay, now this is epsilon m.
Yeah.
Now this speed of the electromagnetic wave can be written as, instead of mu m, I can write mu naught, and instead of epsilon m, I can write dielectric constant k into epsilon naught, because dielectric constant k is given by epsilon m by epsilon naught. So epsilon
Yeah.
m can be written as k into epsilon naught.
Yeah.
So k into epsilon naught, and here is 1 divided by this. This will be 1 divided by. Basically, this is whole thing divided by 1.
Yeah.
Now, this is equal to, C is equal to 1 upon mu naught into epsilon naught. So from here I can write mu naught into epsilon naught is 1 by mu naught into epsilon naught is equal to C. So V can be written as C divided by under root of K. Now what is V? V is C by 2. We have
Yeah.
find it here, C
Yeah.
by 2. So put the value of V, that is C by 2, and this is equal to C by under root of K. C and C will be cancelled out, so K is equal to 4 you will get. Under root K is equal to 2. Squaring
Yeah.
both sides, you will get 4. So dielectric constant is basically 4. So now you can take the screenshot. So in this these types of question, you will